Hey guys, I'm back. It's Mr. Grice for Algebra 2, Unit 4.7, 4.14 practice test. All right, so due to technical difficulties, we left off at number 6. So we're going to go ahead and get started here. So graph the following system of inequalities. Looking at my first guy up top, I know that it is linear. Okay, so when it's linear, I need to know what my slope is. So it's 2 over 1. I need to know my y-intercept, 0, 7. Looking at my symbol, I can see that it is closed. Some people have been saying solid, same thing. And then I'm going to need to shade above this. So as I come over here, I start at 0, 7. I'm going up 2 over 1. That's as far as I can go. So then I'm going to go down to left 1, negative, negative makes a positive. And there is my line. Okay, I'm using a straight edge to graph and to make sure that is nice and straight. Now, it tells me to shade above, but I'm not going to do that yet. Why? Well, because I've got something else to graph. And this is a quadratic. I look at my pattern. It's negative 2. My vertex is negative 6, negative 1. And now, sorry, I'm going to come back over here. Looking at my symbol, I am open or dashed, and then I need to shade below. So at negative 6, negative 1, right, I am open, and now I follow the pattern. I'm going to go down 2 over 1, 2, 4, 6, 8 over 2. Okay. Now, looking at the different sections, I have section 1, section 2, section 3, and section 4. Okay, I need to be above the blue. So above the blue means I get rid of 2 and I get rid of 3, but I need to be below red. So I only get to color in this little bitty section right here. Okay? Now it's asking me to find a sample solution. Sample solution is anywhere within the shaded area. So I picked negative 6, negative 3. Okay, now that's not the only point. There are lots of other ones that you could pick from, but negative 6, negative 3 is right there. You can clearly tell that it is shaded. All right, number 7. Okay, so number 7, I want you to do this one on your own. Couple things that I want you to notice right away, that our first one is an absolute value, and our second one is a quadratic. Okay, so go ahead and pause the video and good luck. Okay, so you can see that I have graphed the system. Now I need to figure out where I'm going to shade. All right, now this one I'm going to talk about doing more in your head. I need to be below my absolute and below my quadratic, and the only way I can meet both of those criteria is this section down here. Okay, anything that is below both of them is part of my solution. Okay, remember, it's got to work for both situations. Now, a sample solution, once again, sample solution anywhere in the shaded area. You know me, I like to be nice and safe. So my sample solution is at 0, -5. Okay, last page. Here we have to write the system of inequalities for the following graph, then identify a point in the solution set. Okay, so let's look at our absolute value first. The first thing that I notice about the absolute value is that it's open or dashed, and that we shaded below. So that is the less than symbol. My vertex right here is at the point 1, -3. And then my pattern, it looks like it's 1, 1, 2, 3, 4. Let's check it. 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. So our pattern is 1 over 4. So as I go to write that, I know that it's absolute. So I have y is less than 1/4 absolute value of x minus 1 minus 3. Okay, now let's look at the quadratic. The quadratic is closed and solid. And for the quadratic, we also shaded below. So that is a less than or equal to. My vertex is at the point -4, +7, and that my pattern is a -2. Okay, so a equals -2. So as I come over here to write this, we get that y is less than or equal to -2 x plus 4 squared plus 7. Okay, and then figuring out a solution, just go somewhere in the shaded area. And the point that I chose right there is -4, -6. Okay. Now, determine the average rate of change in the function f of x equals x squared minus 8x minus 9 from 0 to f of 3. So what that means is I'm going to take this f of x and I need to plug in 2 points, or 2 values. One time I need to plug in 0, and the other time I need to plug in 3. And tell me what the answer is. Plugging in 0 is easy because 0 squared is 0, -8 times 0 is 0, and then I'm left with -9. So I know that one of my points is 0, -9. Now my other point, the 3 point, 3 squared is 9, minus 8 times 3, which is 24, minus 9. Okay, when you get all that, you should get -24. Now, another way to do that is to plug that equation into y equals. This isn't that equation, and go to graph and look at it that way. Or you can just plug those points into your calculator. Okay? Now, that's not my average rate of change because I need to find the y2 minus y1, x2 minus x1. So I start at -24. I have -24 minus -9 over 3 minus 0. Well, 3 minus 0 is easy because 3 minus 0 is 3. -24 plus 9 is -15. And when you divide those, you get an average rate of change of -5. Okay, complete the square in order to write the equation in vertex form. So there's my A, B, and C. When we're doing completing the square, we need to take B divided by 2 and square it. So that would be 10 divided by 2, which is 5, and 5 squared is 25. So I have x squared plus 10x. We talked about creating a space, minus 29, and then having another space. And that is where we're going to put the plus 25 and the minus 25. Let me zoom in a little bit. Okay, so plus 25 and minus 25. What's in parentheses, this is what I need to factor. So what numbers multiply to get to 25 and add to get to 10? Yeah, it should be 5 and 5. Now, since my leading coefficient is 1, I can say that that is really x plus 5, and then -29 minus 25 is -54. And then as I go to rewrite this, it would be x plus 5 squared minus 54. All right, and we are down to the last two. A ball is thrown off the top of a building at the height of the ball in feet is given by the function. H equals -16t squared plus 64t plus 80, where t is the time measured in seconds. So I always like to draw a little picture. Here's our building, windows. There's somebody and they throw a ball and then it hits the ground. Okay, so what is the maximum height that the ball reaches? To find that, that is the vertex. Okay, the maximum height is the vertex. So the first thing that we have to do is the opposite of b over 2a and then plug in. Okay, so x equals the opposite of b, so -64 over 2 times -16. Well, -64, and if you don't know 2 times -16, you're using your calculator to get -32. And then I have -64 divided by -32 to get +2. So this is actually the time, so 2 seconds. But that's not what they want. They want to know the height. So I would take the 2 seconds and plug it in. So -16, 2 squared plus 64 times 2 plus 80. And plug in 2. The easiest way to do this would just to be to use your calculator. -16 times 2 squared plus, right, plus 64 times 2 plus 80. And then we get our height of 144. So that is h equals 144 feet. Sorry, there's our equation right there. So our first answer is 144 feet. So right here is 2 seconds. But now I want to know, where does it hit the ground? When? How long does it take? Well, that's when the height is 0. So if the height equals 0, I'm going to use my original equation, negative 16t squared plus 64t plus 80, set that equal to 0, and solve. So to do that, I am factoring. All right, the first thing I need to do is take out the GCF. I always check the biggest number first. Does 16 go into 64? Yep. Does 16 go into 80? Yep. Awesome. So I'm going to take out a GCF of negative 16. Okay, my leading coefficient is negative, so my GCF needs to be negative. And then I have a positive t squared minus 4t minus 5. So I need to factor this now. So I need numbers that multiply to negative 5 and add to negative 4. The only factors that multiply to 5 are 1 and 5, and one of them needs to be negative, and it's the negative 5. So since my leading coefficient is 1, I can break this down to t plus 1 and t minus 5. Since I'm running out of room, I'm just going to move this up to here. Everything with a variable, I need to set equal to 0. I would subtract the 1 and add the 5. Time can't be negative, so my answer is the 5, and that's going to be 5 seconds. Okay? Well, guys, that's it for Algebra 2, Unit 4.7, 4.14 Practice Test Video 2. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. Otherwise, this is Mr. Grice signing off. Thanks for watching.